Hello everyone, welcome to today's class. We are discussing 15 questions of general aptitude for GATE 2026 exam. As you know, GATE exam is just round the corner and general aptitude is for 15 marks in your paper. So like it or hate it, but you can't ignore it and you have to practice questions of general aptitude. And that is why every year we bring this series of 15 questions of different topics of quantitative aptitude and logical reasoning to encourage you to start solving questions of general aptitude if you have not yet started. Now last year many students told me that the questions we discuss here are of a little higher level, a little tougher level, and that is why in this year's series I will be discussing basic simple questions which 99% of you should be able to solve. If you want to solve questions of a little higher level, then you can watch the videos of last year or even the year before that. All of that you will find in Exergic's YouTube channel. I will also give you the link in the description box below. So let us start with today's questions. So the first question is on the screen. It is from the topic of probability. Please pause the video, give the question a try, and then you can cross-check with the solution that we are discussing. For every question, don't take more than 2 or 3 minutes. So sit with a timer so as to reinforce the habit of practicing questions within a time limit. Alright, so let's start. A deck of cards contains 6 cards numbered 1, 2, 3, 4, 5 and 6. If 3 cards are randomly selected one by one from the deck without replacement, what is the probability that the numbers on the cards are consecutive integers in increasing order? So we basically have a deck of cards with this 6 cards numbered 1, 2, 3, 4, 5 and 6. This is not your deck of playing cards, right? You simply have 6 cards numbered 1, 2, 3 up to 6, and you are drawing out 3 cards one by one from the deck. So what is the probability that the numbers that you get are integers in increasing order, right? So suppose I am going to have if I'm taking out the cards one by one, I basically want in consecutive integers of increasing order. Consecutive integers of increasing order means I want something like 1, 2, 3, or I want 2, 3, 4, I want 3, 4, 5, 4, 5 and 6. So these are the 4 possibilities that we can have, right? So this is nothing but my event space. As per the language of probability, this is going to be my event space, which is nothing but we have 4 possibilities. What about my sample space or the total possibilities? Sample space or the total possibilities, I have 6 cards out of which I am selecting 3. So 6C3, right? But notice that the order in which the cards are appearing is also important here, right? Because the probability is that they should be consecutive integers of increasing order. So the arrangement or the order of the numbers is also important, and that is why I am also going to multiply this with the 3 factorial, because in each selection the cards can be in different orders, or the numbers can be in different orders or in different arrangements. So firstly, from 6 cards I am selecting 3, and then the 3 numbers can be arranged in 3 factorial different ways, right? So this is going to be simply 6 factorial upon 3 factorial, 3 factorial into 3 factorial. So this gets cancelled and I will be left with 6 into 5 into 4 or 120. Right? So what is going to be the required probability? It is going to be 4 divided by this 120. So required probability is 4 by 120 or 1 upon 30. Option B. Clear? So we are finding out the event space first, that is the number of combinations we can have of 3 consecutive integers in increasing order out of the 6 numbers given. So 1, 2, 3, 2, 3, 4, 3, 4, 5 and 4, 5, 6. 4 such cases. What about the total number of possibilities? I have 6 cards out of which I am selecting 3, and then the 3 cards that I have selected can also be arranged among themselves, and we are taking that into account by multiplying with the 3 factorial. So that gives me 120. So required probability is 4 upon 120 or 1 upon 30. Alright, let us look at the next question. This is also a question of probability. 2/3 of the roads from A to B are at least 5 miles long and 1/4 of the roads from B to C are at least 5 miles long. If you randomly pick a road from A to B and then randomly pick a road from B to C, what is the probability that at least one of the roads you pick is at least 5 miles long? So very simple question. The wording is a little tricky, or it's a little long, but the question itself is very simple. We have got 2/3 of the roads from A to B are at least 5 miles long, and 1/4 of roads from B to C are at least 5 miles long, right? And if you randomly pick a road from A to B and then a road from B to C, what is the probability that at least one of the roads you pick is at least 5 miles long? So this 5 miles long is something which is constant throughout the question, and it has been just added to make the question a little long. Basically, the probability of selecting a road from A to B which is at least 5 miles long is nothing but 2/3, right? 2/3 of the roads are at least 5 miles long means if I randomly pick up a road from A to B, then the probability that it is at least 5 miles long is 2 by 3, right? So we can say that if I want to consider my event, right? My event is that the road is at least 5 miles long. The event is the road is at least 5 miles long. So the probability of the event happening when I select a road from AB is 2 by 3, and when I select the road from BC is 1 by 4. So the probability of the event not happening, that is the road not being at least 5 miles long, is when I select from A to B, it is 1 by 3, and when I select from BC, it is 3 by 4. Now what is the question? What is the probability that at least one of the roads has to be 5 miles long, right? So either the event happens in AB, or it happens in BC, or it happens in both. That is what at least one means, one or more, right? So either in AB but not in BC, or it is in BC but not in AB, or it happens in both AB and BC. So the probability that the event happens in AB is 2 by 3, and it does not happen in BC, so 3 by 4, or it happens in BC, so 1 by 4, and it does not happen in AB, so 1 by 3, or it happens in both AB as well as BC. So this is going to be the final probability. Okay, so we'll simplify. It is going to be a 6 by 12 plus 1 by 12 plus 2 by 12, or simply a 9 by 12, or it is going to be 3 by 4. So as I said, the question seems a little long and lengthy, but actually the concept is very simple. We have to find out the probability that at least one of the roads we pick is 5 meters long. So at least one means either AB but not BC, or BC but not AB, or both AB and BC. And as you know that the multiplication symbol corresponds with and the plus symbol corresponds with or. So the last question of today's class, another question on probability. A couple decides to have 4 children. If they succeed in having 4 children and each child is equally likely to be a boy or girl, what is the probability that they will have exactly 2 girls and 2 boys? So a couple is deciding to have 4 children and each child can either be a boy or girl, and they have the equal probability of being a boy or girl. So what is the probability that they have exactly 2 boys and 2 girls, right? So I want 2 girls and 2 boys, right? So each child being either a girl or boy has a probability of 1 by 2, equal probability. So the probability of being a girl is 1 by 2. Similarly, probability of being a girl is 1 by 2 for the second child. For the third child, probability of being a boy is 1 by 2, and the probability of being a boy is 1 by 2 for the fourth child as well. But we also, it's not necessary that the first 2 children are going to be girls and then boys, right? So they can all be arranged. We can have boy, girl, we can have boys and then girls, we can have a girl, then 2 boys and then girls. So it can be in different arrangements, right, or different orders. So we have to consider that as well, and what is the number of ways by which we can arrange 4 items of which 2 are identical, 4 factorial divided by 2 factorial into 2 factorial. Clear? So each of this child has an equal probability of being a boy or girl, which is 1 by 2. So that we are taking into account 1 by 2 into 1 by 2 into 1 by 2 into 1 by 2. But we also have to keep in mind the arrangements which are possible. For that, we are going to take 4 factorial divided by 2 factorial into 2 factorial. So we are taking into account the various order in which the boys and girls can be there, right? So this we will simplify. This will be 4 factorial 4 into 3 into 2 factorial, right? So 2 factorial gets cancelled and I will be having a 2 here, and this is a 4 into 4, 16. So this is a 4 and 3 by 8. So the required answer is going to be 3 by 8. Clear? So for each child, we are going to take the probability first. So the probability that the first child is a girl is 1 by 2. Probability that the second child is a girl is 1 by 2. Probability of the third child being a boy is 1 by 2. Probability of the fourth child being a boy is 1 by 2. But this order is not necessary. As I told you, there can be various orders in which the boys and girls can be there. So to account for that, we are multiplying it with 4 factorial by 2 factorial into 2 factorial. Clear? So this is the practice question for you. If x is to be chosen at random from the set 1, 2, 3, 4 and y is to be chosen at random from the set 5, 6 and 7, what is the probability that x into y will be even? So x, y or the product of x and y is going to be even. The options are 1 by 6, 1 by 3, 1 by 2 and 2 by 3. So solve this question. Whatever answer you get, please comment below this video. The correct answer will be updated in the first pinned comment below this video within the next 24 hours. So you can come and cross check whether your answer was correct, and in the meanwhile, please write down your answers in the comment section as well. I hope you found this video helpful. If you have any doubts or queries regarding the questions that we discussed or any topic in general, please feel free to comment below and I will be getting back to you. Thank you so much for watching. All the best.